May I please know who all are on the line? Uh, you might have heard all the hype around big data and this stuff coming in. So we're going to discuss that thing, now. So it's like, yeah, coming to MongoDB, a recent report from Gartner suggests that close to 25.3 zettabyte of data would be available in the digital market by 2020. And that's actually a very huge amount of data to be talked about. So to handle or process this data, the present RDBMS systems we have are not that capable. The max volume of data which they can actually cater to is close to terabyte of data, which itself is like, a bit difficult to handle. The SQL servers, the oracles, the all. So that is what the case is. So when we talk of big data, first thing is, why do we want to process that? If the digital market is actually producing around 25.3 zettabyte of data, why do we need to analyze it? What advantage would that give me? So that answer would be, every day so much applications are being done, so much information of a customer is actually going out on the web, and we are not using that. Suppose a customer browses, some products regarding what he wants to buy. He searches for an iPhone, he searches for a Samsung. So everything is getting recorded in some weblog, it is getting stored in some database. So whenever the same customer logs in back, if we have the data, what he has browsed in the previous, we can actually look and see, recommend things to him. So that is where these things come up. So one thing is, if we are actually able to analyze and process this big data, it can actually be revolutionary, and that is what is keeping the big data thing alive. That is what is the hype all around, that if we are able to process the data which is being generated from Flipkart, Snapdeal, Facebook, Twitter every day, it can be revolutionary. The moment we put a like, the moment we comment on FB, something somewhere is getting recorded that so-and-so name has liked so-and-so page, and if we go back and study how the person has gone by through 1 month or 1 week, we can actually see a trend, and we can have a kind of a character or some properties of that specific person. So big data has immense potential, that's for sure. All the Gartner reports, everyone same. So coming to big data and MongoDB. So MongoDB, I'll tell you what is actually the changing landscape. There used to be a time when, RDBMS used to rule the world. Everything used to actually happen through RDBMS. But by time RDBMS is actually, it is not being able to go up to the mark and, keep up with, analyzing and, processing information. So this big round circle you can actually see on the screen. NoSQL is fast coming up to cater to the unstructured data which is being generated from Twitter, Facebook, the weblogs every day. And there are some other services like, this and that, happening in the database, which are able to come up, which are not able to come up. So when I say of NoSQL, what it is actually, the basic person would understand that NoSQL is, we are not using any SQL in that. But that won't be correct. NoSQL means it is not only SQL. All the SQL which was being used in the RDBMS will continue to use that SQL. Plus, it's not only that SQL, we'll be using some extra features apart from the SQL to make and process that big unstructured data which is available with us. So the agenda for the topic would be, we'll be discussing what MongoDB is. And then we'll actually go with the comparison of how relational databases fare with the MongoDB, and then what the MongoDB will achieve, why actually we're going with the MongoDB, and when can we actually apply whatever we have learned in MongoDB if we have come through that stage, and where we can actually apply that. Yeah. So to start with, MongoDB, the name MongoDB has actually come from humongous, because the volume of data we are actually dealing with is actually humongous. So from humongous, the Mongo has come, the DB as a database. So MongoDB as a whole, I'll define it as a NoSQL DB, which is scalable, high performance, and it is an open source NoSQL database, and it's written in C++. So the basic thing is scalable. So what scalable is, the concept which MongoDB comes up with is, because the amount of data is being increased at a very fast pace, and because my normal relational database servers are not able to keep up with that volume, I'll actually scale the database. It means I'll actually use the help of a commodity hardware, and will actually implement commodity computing. So for you all, the terms might seem a bit new, but just relax, they're all very simple. So when I say commodity computing, it's like using very large commodity hardwares, like low cost hardware systems, to actually scale up the system. It means, suppose I won't be having one server, I will be having 10 nodes, it means 10 systems, and the data would be distributed across the 10 systems like that. So everything won't be stored in one server. Some data would be stored in one server, some will be stored in the second, some will be stored in the third, and go on up to 10. So this I'll call a distributed systems kind of a thing. So that's what the concept behind MongoDB is. And the scalability I'm talking of right now is called horizontal scalability. I am scaling the database horizontally. I'm adding one node each time whenever I see the data is increasing. And whereas the scalability which used to happen in the RDBMS, that used to be vertical scalability. Suppose I have a system of, say, 500 GB of storage with around 4 GB of RAM. If my data is increasing and the performance is not coming up, what I'll do is I'll increase the RAM, I'll increase the storage. So that is increasing the vertical scalability, when I increase the capacity of a particular system. So that's vertical, but all the NoSQL, the Hadoop, the MongoDB, what these systems do, these systems employ horizontal scalability. So horizontal scalability is first term which you guys should be very clear with when I talk of MongoDB. Okay, so that is the same point which is specified in the second point, that new database technology like MongoDB is the need of the day to facilitate horizontal scaling of data layer, easier development, and ability to store more data at a magnitude more than what was used in the past. And another, the third point is also very interesting to note. There are actually multiple NoSQL flavors to go into. So when these NoSQL things came up, there were 4 models which actually came by. One was a document model where every record used to be stored in one single document. And to be a bit more illustrative, suppose me, Namit, has an FB account. It means I will have only one record of myself in the MongoDB. All the likes I make, all the comments I make, all the famous personalities I'm subscribed to, all the people I follow, every information would be stored into one single document. That is a document-oriented data store, a document-oriented NoSQL, and that is what MongoDB is. Apart from this, we have column table stores, we have wide column stores, and we have graph stores. Like these graph store, its example is Neo4j, column store it's Hive, wide column store it's HBase. So that's also NoSQL databases which are being used with several different flavors. But when I talk about MongoDB, every record will be stored in one single document. So that's what I mean by a document data model. When you come to the third point, yeah, MongoDB is developed on document data model. I'll come to the JSON BSON afterwards, which makes easy to code, easy to manage, and yields excellent performance by grouping the related data together internally. So now coming to the JSON or the BSON. So JSON is JavaScript object notation. So JSON is actually everything will be stored in the form of a key and a value. Suppose I want to say in MongoDB in a record that yeah, one very important thing, because it will be very easy for you guys to come up with is like in SQL Server and relational databases, I say that there is a table called employee in which there are rows and columns. The columns are employee number and employee name. So that is kind of a structure in RDBMS. So the first thing is, what kind of a structure will I have in MongoDB? So in MongoDB, the same thing I used to call a table over there, I'll call a collection over here. I won't call a table employee, I'll call there is a collection called employee. Okay. And in that collection, I'll be having documents. The documents are synonymous with rows, like I used to have rows over there. So to illustrate what a JSON is, I'll go back to the first slide. See, when we go here, introduction to MongoDB, behind that, the first pick you can see is actually a leaf, MongoDB return, and just beside that, it's a name, Mongo, type DB. So this is actually a JSON where I'm specifying a key. The key name is name and the value name is Mongo. Then the key name is type and the value name is DB. So this illustrates what a JSON is. Everything will be stored in the form of a key and a value. Yeah. So up till now, I should be like, I'm assuming that what exactly is MongoDB, you guys would be clear with. To sum up, the brief things I've told right now, to catch up with the increasing pace of data, to process it, to analyze it, we wanted something else than RDBMS to come up. That was where, these NoSQL DBs come up. And one such player of NoSQL, document data model, MongoDB is the one which is leading the market, leading the trend, leading the Gartner research in analyzing the big data. Coming up MongoDB, every table in that will be called a collection, and we can actually scale the MongoDB, the horizontal scaling concept you need to keep in mind. Plus that, the way it stores the data, it's actually everything in JSON and BSON. And one very interesting thing, why MongoDB is actually leading the race, with Cassandra, HBase, Hive, Hadoop and everything, it's because MongoDB becomes an internal choice, obvious choice for all the developers, who are dealing with Facebook, Twitter, or the social media, because the data being generated out of Facebook, Twitter is actually JSON. And because the native, code used in Facebook, Twitter is JSON, we can easily import them into MongoDB because MongoDB also deals with JSON. So that is the reason why it becomes an obvious choice, plus the kind of things, I'll tell MongoDB can actually do, and, the kind of functionality that can actually happen. Yeah. So, yeah. So I've covered, a few, but we'll go, why MongoDB or where relational databases was and what MongoDB is, what is the difference, and, I'll compare a bit of them here. So MongoDB is actually developed by Tengen. It's a company which is actually behind MongoDB, and RDBMS, it was developed by EF Cord of IBM. So I assume RDBMS things you guys would be, aware of, like, what used to be in RDBMS. I'll be comparing the same with the MongoDB. So in RDBMS, we used to have a schema, in which we used to specify how many columns are there and the data would be inserted in that. So A table would be there and records would be inserted. Here, it's all schema-less. Like I say, if I need to store the Facebook data into an RDBMS, I say I have one key as name, one key as age, one key as sex, one key as subscription. I'm talking about FB account. So when I'm inserting the record in RDBMS, suppose I've started a subscription to some famous personalities, statuses. So I'll have to put that data somewhere, but for that I'll have to alter the schema because the current column which we have, I can do with that. So first of all, I need to alter the table, then I need to enter. Then the column I've added, all the rows who are already there, I need to add a null for every one of them. So because the data is changing every day, a new column is coming up, RDBMS does not fit into the space. And because of the reason that MongoDB is actually schema-less, we can actually add, delete any row. To be a bit more specific, suppose Namat Taneja has a account in Facebook and it has 5 columns: name, Namat, age, sex, subscriptions, and followers. I use Facebook a lot, so I have the 5 columns. A next person called Navneet comes up, and that person is not much on Facebook and he has only 2 columns, name and age. So we can easily insert that into Mongo. The first document can have 5 key value pairs, the second can have only 2, and the third can have even 100 or 1000. So we can actually, the schema is flexible. We can add, delete columns, and we can actually be very flexible with that. So the tables there are called collections and the records are there called documents. RDBMS used to give us a very rich set of functionalities, whereas MongoDB, if you compare to RDBMS, the kind of functionalities it offers is not great, because I won't say it is not great. It's not to the level of functionalities which RDBMS used to offer, and the reason is very obvious. When I say there is no schema, I can't actually put a join on the collection, the web collection employee and collection manager. So I won't be able to put a join because the schemas of both the things are different. So, and some things become very obvious because it's schema-less. I can't actually have transactions going in. So I'll come to that why transactions. There are 2 things in MongoDB where the functionalities falter, and one is the joins, and one is we can't have transactional things going over here. I'll come to the transactional things later. Yeah. So RDBMS is used for handling structured data, which has a fixed structure, whereas NoSQL we can handle unstructured data as well, which has no schema, nothing. Even the web logs. In RDBMS we do vertical scalability, and MongoDB we employ horizontal scalability. I guess I've also already covered that. So that point would also be fine. We scale the system. Now comes an interesting thing. In RDBMS, the principles involved are as said. I assume you guys will know that atomicity, consistency, isolation, durability. So that was the key concepts of relational databases. When I come to MongoDB, it's actually the opposite. It's base. The name has just been took to clarify that it is kind of the opposite. And the base full form is basically available, soft state, and eventual consistency. Don't go on the words. Don't feel heavy. What this thing is, A stands here for availability, S stands here for soft state, and E stands here for eventual consistency. I'll come to the E part first. When I say in RDBMS transactions can be done, transactions can be done because the system is consistent. If I have withdrew 100 rupees from my account, immediately that 100 rupees deduction, that modification has been done in the database, and my account, it has been debited by 100, and the same has been updated in my account. So the next time I swipes my card and get the cash balance. So that will actually be 100 less than the previous amount, because the system is consistent. Whatever operations I do, immediately that are being reflected in the database. That is RDBMS, full consistency. Whereas when I talk of MongoDB, it's eventual consistency. What I mean by that, this is one of the terms like, horizontal scalability, very specific to Mongo NoSQL. Eventual consistency is also on the same level. It's very important to actually be very clear what eventual consistency is. Eventual consistency is, I have withdrew some amount, but the same would be reflected in the other systems, in the other distributed nodes a bit later. It won't be spontaneous. It will happen, but it can happen after 20 milliseconds, after 20 seconds, after 20 minutes, or something 1 hour. Because, and so now you will say, why this kind of a thing, I can't use transactions? Because these NoSQL databases, they are not actually made to get the transactional thing done. They are actually being made to, process archival data, to process huge data. Suppose I have the Facebook data in here in my MongoDB for 30 days, and I'm doing some analysis on that. So when the 31st day data needs to come and sit in my top of the 30 days, even if it comes after 30 minutes, it's fine for me, because anyways, the 30-day data I have. So I don't actually need the consistency thing here to get my things going. So this is eventual consistency. Every updates made, the same is not spontaneously gone to other distributive nodes. It will take some time. And that is what the thing is. And now suppose I want to say to you, in my MongoDB cluster I have 2 nodes. There are 2 systems which are connected distributedly. So I'll take only 2 to ease the things. Actually the MongoDB clusters can be of 100 to thousands of nodes. For simplicity, I'll take 2. What I mean is, if some operation, if in some class employee, I'm adding an employee Raj, and I retrieve the name of the employees in the collection employee in the second node, the same may not be reflected instantaneously. It will take some time to get synced in between the 2 nodes and the things be transferred. So the same would not be reflected at that time. That is eventual consistency. So, and the state when the first node has not got actually synced with the second node or all the nodes, that state is called the soft state. It means it is still in the soft state. The data, the updates which I have done are still not permanent. They have not been gone to all the nodes. So that is what I mean by soft state. And availability is, the data I'm using won't actually be available. The updates I've done, the modifications I've done, that data won't be available for some time. So it's basically available soft state eventual consistency. So this actually sums how MongoDB actually works. So yeah, coming to the next point. RDBMS stresses on availability and consistency of data. The data should be available all the time and it should be consistent. Whereas here it stresses on availability, the data should be available, and partitioning of data. Like I said, all the data won't be stored actually in one node. And to partition the data and store in multiple nodes in a cluster. I won't be storing everything on one node. I'll be having 100 nodes, and some data, suppose employee ID 1 to 100 would be stored in node 1, 101 to 200 in node 2, 201 to 300 node 3, and so on. So load won't be on one single node. So that is what I mean by partitioning of data. This is also, I'll come to again a very big part of NoSQL thing. Partitioning. Now, what is actually partitioning? So full consistency, eventual consistency. Synchronous update. Synchronous update, the same thing I told, that the update has to be synchronous, and here the update is asynchronous. So RDBMS, they actually have the normalized data, and MongoDB, the data is actually denominalized. I need all the data there in the universe and do analysis over top of that. And because a DBMS is actually very transaction and consistency friendly, it's actually very favorable for the OLTP thing. Whereas in MongoDB, because I need insights, I can actually work on the OLAP data. I have the data over a past, say, 20 years, and I can run things on and get some insights out of that. So once we actually have a bit fair understanding of what MongoDB is, we'll actually run a practical of how we can actually create a collection, how we can insert rows, how things will actually go by. The next thing is what MongoDB will actually achieve. I have two, the X's are, one is scalability and performance and one is the depth of functionality. You can easily see what MongoDB is trying to achieve is somehow the, see where RDBMS is, the depth of functionality is very high, but the scalability and performance factor, the performance is very weak and the system is not scalable. Whereas if you see the key value stores, key value stores are highly available, they're highly scalable, and the performance is very high. But the kind of functionalities they offer are very less, not even comparable to the RDBMS. So what MongoDB tries to do is it tries to bridge the gap between both the things, come up as a point where the system is highly scalable, it is highly performance efficient, plus I'm not compromising on the depth of functionality. So that is what actually MongoDB is going to achieve, and that is the reason behind all the success stories behind MongoDB coming up and replacing all the MySQL things and all. Yeah. So here I'll go with what are the key features of MongoDB. Almost some of the points I would have told, I will just go back. It's a JSON data model with dynamic schema. JSON, I've already told, dynamic schema, it will, we can add, delete columns, anything, it's schema-less and all those things. Then, because I told it has enough set of functionalities, MongoDB has full index support for the database. We can create indexes, we can delete indexes, we can drop indexes, everything is there what used to be in RDBMS. The next thing is built-in replication and high availability. So replication is another thing which, two things I like to say in this very fast. Two very important concepts in NoSQL MongoDB is replication and sharding. To talk of replication first, replication is my data would be replicated across all the distributed nodes in my cluster. When I say I have a 100 MB file which I need to store in my MongoDB, so that 100 MB file would be divided into chunks. Say I've divided into 3 chunks A, B, C. That 100 MB file is divided into 3 chunks A, B, C. I'll say in one node it will be A and B, in the second node it will be B and C, in the third node it will be A and C, in the fourth node it will be B and C. So different combinations of the ABC, they will be scattered across all the clusters. So the reason behind this is replication. I'll be replicating every chunk multiple times. The number I will specify, say I want the replicating factor to be 3. So every chunk would be having 3 replicas and that will be stored across the distributed nodes. So what is the reason behind that? So what I mean by this is even if node 7 fails, it goes out of context, the power goes off or the system crashes, I can still retrieve all the ABC from other different nodes and get my full file back. If the client wants, I want the 100 MB file back and the node 7 and say node 3 is gone. So I still don't need to worry because the data is replicated and I can anyways get the data out of that. So that is one thing where replication comes great, and almost every new NoSQL DB is actually using it. And the second concept I told you was sharding. Sharding is I will specify a shard key, and on the basis of shard key, I will be storing my data. I will be specifying a shard key employee ID. From employee ID 101 to 200 stored in node 1. From 200 to 300 stored in node 3. 300 to 400 stored in node 4. So on the basis of a shard key, I am sharding the database and that is being stored everywhere. So The third point, highly availability and built-in replication that I've gone through. So the fourth thing is aggregation framework and the MapReduce. This is one thing which is actually, MongoDB has come up and it is great. The MapReduce thing you would have all known, all the hype around that. So MongoDB has an internal MapReduce program which maps the problem first, divides them into sub-problems, then aggregates, reduces them and presents the output. And the aggregation framework works on a similar basis like we used to do group by in the SQL, group by name, group by number. So that thing here will be managed by the aggregation framework. We'll cover that. So then comes auto sharding for the horizontal scalability. As I said, horizontal scalability is a primary thing in NoSQL. The system would be scalable, but how it will be scalable? My data would be stored in 10 nodes instead of 1 node. But how in 10 nodes? That's where sharding comes in. A shard key has to be specified. Okay, so and so data from here to here goes to node 1, goes to node 2, and all those things. I hope replication, sharding, horizontal scalability, failover, eventual consistency, I'm actually making sense and we are all on the same path when I talk these terms. The next point is rich document-based queries. The kind of functionalities, we can easily write queries very similar to SQL. That gives MongoDB a very big advantage. Then it's fast in place updates. The updates we do are very fast and we can actually do that in place. Now to store very large file, like I told, every data in MongoDB is stored in JSON or a JSON, but there is a limitation. The maximum document size can be 16 MB. It can be more than 16 MB. If it crosses that, another document have to be made, with the same ID, like I specified document 1 and document 2 both pertain to the name Namit, something of that sort. So GridFS is actually a file storage of MongoDB for documents greater than 16 MB. Suppose I have a 1 GB video, 1 GB movie which I want to store in MongoDB. So that MongoDB will store in GridFS. What GridFS does is it will divide the movie into chunks, store it into 2 collections. One is files and one is chunks. Files would actually contain the metadata about the data, and the chunks could be contain the chunks which will actually have the file. So you just want to know GridFS is file storage system of MongoDB for storing large data above 16 MB. Yeah. So I would have covered what MongoDB is, and I would have even covered why MongoDB is required. So, but to just go through, I'll quickly go through, because the system is very agile. It's not like I've done something now, I can change my system tomorrow. It's completely agile. If some requirement comes tomorrow, I need to do this, I need to do this modification. The schema is very flexible and I can actually do things. So data is stored in JSON like documents with dynamic schemas providing powerful flexibility and simplicity. Rich data types, document-based querying reduces development for modeling rich domain objects. That's what he says. Everything is very rich. It's very agile. And fast in-place updates have covered. Then the MapReduce thing is also available for flexible. So agility basically is, it allows me to be flexible. Whatever requirements come, I can actually deal with that. Scalability I've all covered. Horizontal scalability is there without compromising functionality. That's the key. Allow users to build and grow applications more rapidly. Auto sharding enables easy distribution of data across many nodes. Though I've covered that before, I've told it before, because it is a very important concept, auto sharding. Because my data won't be stored into one single node, it will be distributed across several nodes. I need some parameter of how the data will go. That is where sharding comes into the picture. On the basis of a shard key, data will be distributed among different nodes. And when it is done on its own, it's auto sharding. So that's again, what is told over here. Then replica sets. The thing I told you, replication, that is actually in sync with replica sets. So I'll be creating replica sets, and what that will help me is, that will help me come above failover. Even if, the example I give, even if the node 3 and node 7 goes out, I can still have the data. And that's a very big improvement over what RDBMS used to do. In RDBMS, whenever the server used to go out, we were like, what has happened? The server has gone up, we don't have the data and all those things. But here, everything is replicated. Even if the system has a failover, we can still retrieve the data. And it's enterprise readiness. It's, the technology is very robust, and data integrity is guaranteed through journaling and replication. So coming to journaling, what journaling is, I'll ensure that every write I make on the database is actually journaled first and then written to the disk. So that thing ensures that the integrity of the data is maintained and the same is conveyed to the disk. Yeah, so I would have covered in that when MongoDB, but basically MongoDB I use when the application data is inherently unstructured, because if the data is only structured, then RDBMS would be the good buy. So now you will say, you're saying big data is coming up, the RDBMS space is going down, it means there won't be any SQL Server or Oracle. No, that is not the case. The domains where RDBMS used to work, they will continue to work over there, because wherever the data is structured, that becomes an obvious choice. But whenever the data is inherently unstructured, most of the data is unstructured, that's where MongoDB is out of the picture. So any rich data models that don't require joins between them, there I'll be using MongoDB. Any type of analytics, if there is a analytics application, see a website, I need to track some website activity, what that activity is doing, everything is getting stored into the weblog. So that I want to know how many wasted users are wasting the site, how many anonymous users are visiting the site, from the geography they are, for how many time they are actually staying on the website. All those information, if I want to have some that kind of event, MongoDB becomes an obvious choice for that. So, and wherever high availability is required, MongoDB's replication systems, it provides automated failover. The same thing I told, the concepts are very simple. You just need to see high availability. I'm very sure everyone is here aware what availability is. I've covered that several times. The data should be available. And MongoDB's replication systems provide automated failover, because the system is replicated. Even if some of the nodes goes off, we can still retrieve the data. So we have actually come over the failover thing. Then the sharding thing, if you have a lot of data but want to run that on a commodity hardware means several nodes, a very low cost hardware, a distributed system. That's a commodity hardware. So whenever we have a lot of data and want to run that in a distributed system with very low cost hardware, MongoDB sharding can be very quite compelling, because that's what it has been made for. So now you will tell that everything is told, but can you actually give me a specific use case where I can use MongoDB? That is where in the social media interaction and the sentiment analysis, these things are coming up. Recently I found a study where using MongoDB, a survey has been done to see, a research has been done, analysis has been done to see whether iPhone is better or Samsung is better. So what is being done is, we have iPhone page on Facebook, we have a Samsung page on Facebook, we have iPhone page on Twitter, and the same with Samsung. So we can actually analyze how many likes have increased for the Samsung and the Twitter, Samsung and the iPhone on the Facebook since April 1st. See, my parameter is since April 1st, 2013, I need to see whose popularity is on the rise. It's Samsung or the iPhone. It's Samsung Note 3 which has come up, or iPhone 5s. People, what they are actually in for. So if I see both the Facebook pages, the likes, how much they have increased, how much comments they are making, and the comments which they are making, whether they see good of Samsung or iPhone. So same with Twitter, same with YouTube. The tweets which people are making, are they pro Samsung, are they pro iPhone, and all those stuff, whether they have tagged iPhone and all this stuff. Same with YouTube video. So I'll get all of their data into MongoDB using APIs. APIs is application programming interfaces. Using those APIs, they can actually get the data. APIs would be called. It will be put on the Facebook system, and I'll get the data. So suppose I want to have the Samsung data for all the three. So for a keyword Samsung, Facebook will be giving all the data to MongoDB. For the search word Samsung, YouTube will be given, and the same with Twitter. Once the data is into MongoDB, we can do our analysis, we can do the aggregation thing, we can do the pipeline thing, and the same can actually be, on top of MongoDB. We can actually, use any reporting thing like, Tableau, Pentao report and create multiple reports. So this was what my presentation was all about, to give you a brief understanding of, what MongoDB is, why MongoDB is, what is a NoSQL system, where I can put in MongoDB, and for the present, so that you guys should not feel it was only theoretical. Can I see something running, where MongoDB can come and how collections are made? I'll just give you a feel of, how we can actually, present that thing. So I'm opening a command prompt, and first of all, changing my present directory where MongoDB is placed. So this is where my MongoDB is. To show you, can see MongoDB bin. So this is actually the installation, the whole MongoDB thing I have in my system. This is the bin, and inside the bin there are so many processes which needs to be done. So I've gone to this directory. I'm in this directory. I'm first running MongoDB. I want the MongoDB is Mongo database server. I want the instance to run that runs on port 2707. It means everything I enter on MongoDB will be actually entered. So I'm initiating a MongoDB process, Mongo database server, where everything I'm inserting, I'm updating would be recorded. So once the MongoDB server is on, the database is ready to actually accept the data, I'll go again to the same path where thing is, and I'll write Mongo. So, if I'm not doing that fast, first of all, I changed the directory over here and then wrote MongoDB to initiate the Mongo database instance so that MongoDB can be run. Then I wrote simple Mongo. So it's showing, see, MongoDB shell version 2.4.6, the version which currently MongoDB is running, and it's saying connecting to test. It means I've been able to connect to test database in MongoDB. So by default it connects to test. So everything, some UI will also come off MongoDB, but basically MongoDB is a command based kind of a thing which runs. So if I actually want to see what all databases are there currently in my MongoDB, so the command is show databases, show DBS. So it's showing only a local database is there with so much of space. So now suppose for your reference and all, what we have gone through, I'll create another database, say training. Okay, so I'm using use training. Use training will actually create a database named training. I put enter and see it has shown switch to DB training. Now the database I'm working with is the training database. In the training database, I need to add, I want to make one collection, and that collection name is names. All the person who are attending. So db.people. The collection name, the table name I'm making is people. DB is the instance which I use to do these things. DB is the instance which actually connects with the people collection in the training database. So what I'll do is db.people.save trainer Namit Taneja. So this is actually a JSON if you see, trainer Namit Taneja. So trainer is the key and Namit Taneja is the value. So when I put enter, see This is gone to the next line, and some things have happened in the back end, on the MongoDB. Some things have got stored. See, if you can actually see file allocator, done allocating data file, data DB training, that is where the data is getting stored in my local system. So now if I want to see what is there in my people database, so first of all, we will see is, are we, how many databases are there? Are we able to see a new training databases over here? See, first of all, it was only the local. Now the training has also come out. And now when I see, I'll again say use training. Once it is shifted to that, I want to see what I have in that. So I'll do db.people.find. DB is the instance, people is the collection name, and I want to see the .find is like, to see what I have here in this collection. So see this. The ID, object ID is like, the MongoDB generates on its own. So it is showing the trainer is Namit Taneja. To tell you it's schemaless, I will add another, thing. DB people.save. Name is Navneet. And age is 24. Okay. So I'm adding another record. So the first thing, if you can see ID, object ID 527, this trainer Namit Taneja is one document. A document with Namit Taneja as the trainer. The next thing I've seen, now we like to see what it has. See, the first thing had the key as trainer and the name is Namit Taneja. And the second is, it has two columns, we can say. The trainer was the first column in the first document, and the second I have a two more, name and age. So MongoDB can actually go with that. There was no problem in actually saying the schema. So this actually explains how a collection is actually made, what is the concept of a database, how we can use those things. And if you want to know which all collections I have in my database, it's show collection is showing one is the people collection and what is in its internal system that indexes. And now if you want to remove, all the things, I can do it like this. So now I don't think the people think it has nothing because I've removed that. So if I'll show you show DBS, it has the local in the training. I'll delete the training, for my reference, use training. I'll do db.drop database. Some error has come, the syntax is not correct. Yeah, so now the training database has been dropped. So now if I will say show DBS, so my training database won't be here. So that was what I had actually, I hope my session would have actually give you some understanding of what big data is, how it's coming up, where MongoDB is in the scene, the horizontal sharding, the all those things coming up. So I hope actually this session would have increased your horizon in the big data, and you would have got some understanding of how MongoDB is and how does that work. So that was all I had for you. Thanks a lot. Yeah, I hope that would have added value. Yeah, thanks.